we're going to solve this integral using Euler's formula. Euler's formula is a powerful tool that helps us survive in the complex plane. But since the real part of the formula contains the cosine, we'll only focus on just that. All right, let's get to it. Now you can go ahead and use integration by parts on here, and that's going to be okay. But for today, we're just going to, play around with the Euler formula, which is going to be this value here, cosine of x plus I sine of x. And as I mentioned, we only are focusing on the real value because that's where the cosine shows up, and that's where we have the cosine in our integral. So what we're going to do is we're going to go ahead and call for the real part. And when that happens, we're just trying to get the real part of this value here. So we have real of cosine of x plus I sine of x. So because we're calling for the real part, this is just going to be cosine. So now we're going to go ahead and rewrite our integral. We have e to the x times the real part of e to the ix dx. And now we're going to go ahead and multiply the e to the x on the inside because that's also a real part. So we have the real of e to the x times e the ix dx. And let's just go ahead and make this more concise. So we have e to the x plus ix dx. And just so you guys can see what this turns to, this is going to become the real part of e. And I'll just do 1 plus ix dx. Okay, not bad. And so now we're just going to go ahead and integrate. We're going to go ahead and use u substitution. So I'll show the work. I have 1 plus ix as my makes du 1 plus I dx, or the 1 plus I to the other side, we have du over 1 plus I is going to equal to our dx. So now we can go ahead and rewrite our integral. We have the real part of e to the u, and then we have times the dx value. So this is going to be du over 1 plus I. So keep in mind that 1 plus I is going to be a constant. And integrating this is just the integral of e to the u. So now we're just going to have e to the u plus our constant. Well, we still have this 1 plus, or we still have that 1 over 1 plus I. So we're going to go ahead and start simplifying now. We're going to think about what that's equal to. So up here, we're just going to do 1 over 1 plus I. And to simplify that, apply the top and the bottom by the conjugate. And what does that give us? This is going to be 1 minus I on the top, and then we're going to have 1 minus I squared, which you'll quickly see that this is 1 minus I on the top over 2. So then back to our integral, what we really have is 1 minus I over 2 times the real part of e to the u. Now I'm just going to go ahead and start rewriting that. Our u value was 1 plus I, so we're just going to go ahead and write that out. We still have our cheese, and now we're going to kind of undo this, I guess you can say. This is going to become the real part of e to the x times e to the ix. And the reason why I'm doing that is so that I can pull that e to the x on the outside. So this is what we have right here. We have 1 minus I over 2 times e to the x times the real part of e to the ix. Okay, we're almost done. Let's go ahead and distribute that e to the x into the parentheses. And the reason why I want that is because I'm going to have 1/2 e to the x minus I e to the x over 2. Okay, that's what that part in front of the real part simplifies to. So now we have the real of e to the ix plus c. And then so now we're going to go ahead and distribute this entire value, the real part of e to the ix, into these two terms. So we have 1/2 e to the part of e to the ix minus I e to the x over 2 times the real part, minus I e to the x over 2 times the real part of e to the ix plus our cheese. So let's think about this. We have 1/2 e to the ix. Just going to go ahead and rewrite the Euler formula again. This is cosine of x plus I sine of x, and then we have minus I over 2 e to the x times cosine of x plus I sine of x, and then we still have our plus cheese. And now let's go ahead and distribute that 1/2 e to the sine x to both of these terms. 1/2 e to the x cosine x plus I 1/2 e to the x sine x. Okay, and now we're going to do the same thing with the other. So we're going to distribute this value, and actually let's distribute the negative part as well. So this is plus, and now we have the real part. Oh, and I realized that I should have put like real right on top there. Okay, so we have the real part of negative I over 2 e to the x cosine x squared over 2 e to the x sine x plus our cheese. Oh my goodness, almost didn't fit on there, but let me go ahead and just rewrite it. Okay, so here is our problem rewritten now that it can fit on the screen. For the first part, don't forget, we're just looking for the real part of this term. So the real part is only going to be the one that does not have the imaginary value, and that's going to be the 1/2 e to the x cosine of x. And then plus, so it looks like the imaginary part is the one with the I here, so we're not going to use that one. We're actually going to disregard it, so I can even cancel it out. And then for this second term, we have a negative I squared. Well, I squared is going to be -1, so the negative times the -1 is just going to be positive. So now what we're going to have is positive 1/2 e to the x sine of x plus our cheese. And that is the solution to our integral using the Euler formula.